This lecture is about healthspan and lifespan. The content refers to the Science Daily article, Living Longer but Not Healthier. As I discuss the details of the study, note the answers to these questions. In addition to the lecture content, you should also think about the study. Here are some example discussion questions for you to think about after you listen to the lecture. This study was published in PNAS in 2015 by Tissenbaum and colleagues. Tissenbaum is from the University of Massachusetts Medical School. Her research focuses on studying the molecular mechanisms of the aging process using nematodes. C. elegans is a type of nematode that is very common in basic medical research. C. elegans is a scientific name for a type of nematode or worm. These worms are particularly useful for medical research because they have anatomical structure similar to mammals, and their genes can be easily altered and visualized under a microscope. In this picture, you can easily see the internal organs. Aging research has heavily focused on lifespan, and we already know that due to new technology, better health care, and better nutrition, the average lifespan of humans has increased over the last century. In fact, according to the WHO, the number of people over 85 years old will increase by over 300% in the next 40 years. Tissenbaum suggests that the elderly population has a large burden of healthcare costs due to the increasing lifespan. She thus focused her research on healthspan relative to lifespan, using nematodes as her subject. She defines lifespan as the period an organism survives, whether in a healthy or frail state. Previous research has already tried to maximize lifespan of nematodes by manipulating lifespan-related genes. These nematodes are referred to as long-living mutants.
It's 3 o'clock.
Healthspan of nematodes can be evaluated using a frail index, which measures movement, feeding, digestive factors, and homeostasis factors in these worms. This is similar to the frailty index used for humans. The index for humans evaluates factors related to self-sufficiency, such as, can you brush your teeth? Can you go to the market by yourself? And factors related to diseases, such as cancer or mental disorders. As reported in previous studies, 4 different long-living mutants were confirmed to have longer lifespans than wild-type nematodes. As you can see, wild-type, the black line, has an average lifespan of 20 days and maximum lifespan of 30 days. In comparison, the mutants range from 25 to 115% longer lifespan, with DAF2 mutant being the longest with 43 average days and a 57-day maximum lifespan. The IFE2 and CLK1 mutants have alterations in their ability to deal with stress, while EAT2 and DAF2 mutants have alterations related to metabolism. They first compared the number of healthy days of wild type with those of the mutants under different conditions. The top two graphs tested the worms under stress, while the bottom two graphs tested overall movement in liquid or solid conditions. Wild-type nematodes could resist heat stress for about 23 days and oxidative stress for 12 days. The DAF and IFE mutants could resist heat stress for more days than wild-type, while only DAF could resist oxidative stress longer. All other mutants could resist almost the same or less stress compared to wild-type. This suggests that while the lifespans were increased for some mutants, their ability to resist stress was not improved, except for the DAF mutant. As for the movement ability, wild-type worms had full capacity for about 8 days in liquid and 12 days in solid. In comparison, only the IFE mutant in liquid and the DAF mutant in solid had full capacity for a few more days than the wild-type. All other mutants had similar or less mobility in both mediums. Let's now look at the number of frail days. Wild-type had 7 days of poor heat stress resistance, 28 days of poor oxidative stress resistance, 32 days of poor movement on liquid, and 28 days of poor movement on solid. In comparison, DAF had more frail days for all tests, with about 20 days and 30 days for stress tests, and 50 days and 40 days for the mobility tests, respectively. The results from both the stress tests and the mobility tests suggest that even though lifespan was increased, neither the number of days or resistance to stresses, nor the number of days of full movement capacity were improved in the mutants compared to the wild-type. While DAF mutant did show some improved stress resistance and no mobility on solid, it also showed fewer days of mobility on liquid. To further emphasize these results between wild-type and mutants, Tissenbaum looked at the overall percent of lifespan in a healthy state versus frail state. So healthspan percent would be the number of days that the worms could resist stress and have full movement capacity as a proportion of the number of total days. 100% for wild-type would be equivalent to 30 days, while for mutants, it varies between 33 and 57 days. In the case of wild-type, they could resist heat stress 79% of their lives and resist oxidative stress 42% of their lives, while they could move well in liquid 30% and in solid 42% of their lives. In comparison, let's look at the most improved mutant, DAF, which showed more days of heat and oxidative stress resistance, as well as more days of mobility on solid. However, it also showed increased number of frail days compared to wild-type. When we look at the percentage of lifespan here, DAF shows 15% more days of poor heat stress resistance, 20% more days of poor mobility in liquid, 12% more days of poor mobility in solid. There was almost no difference in the percentage of health span in the case of oxidative stress resistance. In summary, this shows that while the number of total days increased due to mutations, the proportion of life that was healthy did not increase. In summary, These results suggest that mutations in nematode genes can indeed decrease the mortality rate, or the number of deaths with age, and increase the average lifespan from 20 days to as much as 43 days. However, when homeostasis factors and movement are tested during the lifespan, Tissenbaum and colleagues found that Healthspan did not subsequently increase with lifespan. In some mutants, there were indeed more healthy days, but there are also more frail days. This means there is a longer frailty period. Additional observation found that there were fewer offspring in the mutant nematodes compared to wild type. This has also been seen in previous studies in mice. These findings, along with previous findings, have suggested that Healthspan is evolutionarily optimized. This means that a longer lifespan will not provide just more healthy days, but a balance between healthy and frail days. So how do these results relate to humans? Well, just like in worms, humans may have limitations on increasing the average health span, despite the increase in lifespan. That is, while we have increased the average lifespan with medical progress of vaccines and other medical technology, there is also an increase in cases of age-related diseases, such as cancer and Alzheimer's disease. Therefore, Tessenbaum professes that quality of life must reflect not just lifespan, but the ratio of the health span and the frail period. That ends the lecture for this study. In response to the results of this study, bloggers have made various comments on the Science Daily article. These comments provide different perspectives for discussion. I recommend that you read these listed here, as well as other comments on the Science Daily website. So let's now look at the lecture questions one more time. You now know the relationship between health span and lifespan, and you should be able to use these key terms to describe the content of the study. Regarding the who and the where, Tissenbaum and colleagues from University of Massachusetts did the study. As for the when, well, this study was performed in 2015, and it looked at the lifespan, about 30 or 45 days of a nematode. So the length of the experiment was about 45 days, and it was held in 2015. The what? There were 5 subject groups. 1 is the control, the wild type nematode, and 4 are the mutant nematode groups. For the 2 false, questions 7, 8, and 9, all are false. That's it. Good luck with your discussion.